Let's look at strategies that we can use on how to find a rule for a given pattern. So here we're given two figures made up of these blue squares, and we're asked to draw the next two figures, and then based on the patterns we see, fill in the table and write a general rule for how this pattern is changing in relation to the figure number. So as we take a look at this, we see kind of this square in the middle with a little individual square on each of the four corners. So first, let's just draw what the next figure would look like. So thinking about kind of the first one that we see, there's a lot of ways you could look at this. There's like a 1 by 1 square in the middle, and then there's a 2 by 2 square in the middle. The next one would have a 3 by 3 square, kind of the white space in the middle. You could also count how many squares are on each side here. So the first one you see kind of 3 squares across and then 4 squares across. So this next one is going to have 5 squares across and then down. And then it's still going to have on the corners each of these. And it's got a 3 by 3 square, and that blank space in the middle would be one way to look at it. So then if we extend that one more time, now there's going to be 6 squares across the top. And then the four little squares on each of the corners. So the first thing that I want to do is just for these ones where we have an actual picture drawn, just count the squares that are showing up so that we can put those into our table and start to look for patterns that are happening. So in figure number 1, we see 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12 as we make our way around. So just counting each of those. So the next we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then around the corners 13, 14, 15, and 16 total squares. And you may have seen some patterns as you were drawing these, thinking about kind of what had changed of ways that you could count these more efficiently, or you can just count each one of the squares is also perfectly fine. So let's see, we've got 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then around the corners 17, 18, 19, and 20. So you may already be starting to notice a pattern here as we fill in our table that the number of squares went up by 4 each time. And you may be able to kind of picture those additional squares that you've got in your pictures, kind of thinking about how those got added onto the corners. So different ways that you can kind of think about how that square in the middle is growing. So based on that prediction, I expect if I add 4 again, my next one should have 24 squares in it. So if you do a quick count there, we said there was 6 here across the top, and then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21, 22, 23, 24. So it matches up with what we were seeing, increasing by 4 each time. So even though I didn't draw out the picture, using just this idea of adding 4 each time, I know that the next figure number, if I had drawn figure number 5, should have 28. But then in our table, we don't have 6, 7, 8, 9, and we could fill those in, right? Just keep adding 4 until we got to 10. But do we really want to do that to get to 25 and 100? It would be helpful to have a rule that describes what's happening in this pattern. So here's where starting to make a connection between this repeated addition that we're seeing and what we can write in a rule will be very helpful for us. And so this idea of increasing by 4 over and over and over again, if you think about the types of numbers we know that do that, we know, for example, like 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. Our multiples of 4, those grow by 4 each time as you're multiplying by 4. So when we see repeated addition of 4, what we actually have happening is a rule where we're going to multiply by 4, and that's what's going to cause us to grow by 4 each time. But our rule needs a little bit more than, if that was the entire thing, then our answer for the rule would just be 4 times whatever the figure number is. But we can see if you compare, like here we had 12 squares and 4 times 1 is only 4. And here we had 16 squares and 4 times 2 is only 8. So they're both increasing by 4 as we follow this pattern. Here we had 20, but 4 times 3 is 12 when we're on figure number 3. But the difference between the actual number of blue squares that we had and 4 times the figure number is always off by the same amount, 12 and 4. These two numbers, get back to my pen here. These two numbers here are 8 apart, right? If you're at 4 and you want to be at 12, you need to add 8. And if you're at 8 and you want to be at 16, you need to add 8. If you're at 12 and you want to be at 20, you need to add 8. So that means for our rule, instead of just 4n, we need the 4n and we need to add 8 more. So 4n plus 8. This is telling us that we can figure out how many squares will be in any picture number by taking 4 times the figure number and then adding 8 more. So we can check for like figure number 1. Just move these to make some space here. So figure number 1, it's saying take 4 times the figure number and then add 8. So 4 times 1 is 4 plus 8 is 12. Take 4 times the figure number and then add 8. So 8 and 8 is 16. 4 times the figure number and add 8. 12 and 8 gives us 20. 4 times the figure number and add 8. 16 and 8 gives us that 24. So this matches up with the values that we had already seen. So the +4 pattern that we saw moving down the table, when we go to write our rule, tells us we actually want to multiply 4 times the figure number. And then as we think about, okay, I know now I need a 4n, is that the entire rule or do I need a little bit more? We can compare 4 times the figure number to the actual number of squares. We saw that each time we were 8 short in terms of our number of squares. So it's 8 more than 4 times the figure number. Now that we have this rule, we can use this to fill in some of the larger numbers on our table. So for figure number 10, we can take 4 times the figure number and add 8. So 4 times 10 is 40 plus 8. That means that for the 10th figure number, if we were to keep drawing, we should end up with 48. And 4 times 25 plus 8. So 4 times 25 is 100 plus 8 would give us that 108. And 4 times 100 plus 8 will give us 408. So now for any figure number, we can plug into this rule by taking 4 times the figure number and adding 8. So kind of step 1 in our strategy is draw several figures so that you can start to find a pattern. So we recognize the pattern of increasing by 4 squares each time. Once you see that repeated addition in your pattern, that's going to become a multiplication in our rule because that's what multiplication is. It's repeatedly adding whatever that number is. So 4n is telling us to take 4 times the figure number. That allows us to repeatedly add 4. And then compare that 4n to what your actual number of squares is. So we saw from 4 to 12, we were 8 short. From 8 to 16, we were 8 short. 12 to 20, we were 8 short. And so then we can either add or subtract as needed to match up with our pictures onto that 4n part of our rule.